In the following problem, we're asked to give the product of the reaction. So, and what it has is the following. I'm going to write it exactly as is, and then we're going to analyze that. It says, treat it first with hydrolysis, so acidic conditions, and then we're going to treat it with methanol, and here again acidic conditions. So let's this has several steps. So the first thing that we're going to note here is that this is a nitrile. So this is benzonitrile under acidic conditions, and here you have hydronium. You will protonate at the nitrogen. And so the first thing that you're going to form is, say, the conjugate acid of benzonitrile. That's benzonitrile, protonated. Next, what the first step actually is what it is, but we're going to be analyzing by step. This step is a nitrile hydrolysis. Nitrile hydrolysis, but it goes in several steps, hydrolysis. So what we have here then happening is a nucleophilic attack, acidic condition. So your nucleophile here is going to be water. So we're going to do that. And we are forming now NH. And here I will have H and H. So that protonated intermediate. So what are we forming next? Here, I'm going to draw the lone pair, and I'm going to grab this proton, and we'll see what we're going to form now. And this is OH, and this is NH2, but now you're forming a carbonyl here, and let's see what the nature of the product is. So we're going to have, so now it's protonated, and I have, this is a conjugate acid of an amide, and I'm going to draw it. This is my amide. We're going to do a nucleophilic attack here. And what are you forming? Now you're going to have, this is NH2, this is your phenyl group. Now I'm going to have O negative, and I'm going to have water. And so now you can, there is a proton transfer to make actually the amide, the amino group a beta ligand group. So you can do this, you form a carbonyl here, and this actually will depart by grabbing that proton. So now I have a carbonyl group, an OH, and a phenyl. And what is this? A carboxylic acid. That's benzoic acid. And bottom line, the reaction number one, from benzonitrile, we have hydrolyzed it. We form first the amide. So this is benzamide. And under acidic conditions, the amide continues to hydrolyze to the carboxylic acid. Now we're here, and so that second reaction here is an esterification. It's actually under acidic conditions. We call that a Fischer esterification. So step 2, which is methanol, and acidic condition is the Fischer esterification. And because we're doing that now, I'm going to be erasing this part of the hydrolysis that we did before. because I need the space, right? So here we are. This is step 2 in the reaction. We ended up, after the nitrile hydrolysis, we ended up with the carboxylic acid. And now what's going on in the Fischer esterification under acidic conditions, we will have this is your nucleophile. And under acidic conditions, when you have aldehydes, ketones, or carboxylic acid derivatives that are not too reactive, the acid acts as a catalyst by protonating the carbonyl oxygen, and that makes this carbon more electrophilic, so more prone, susceptible to have a nucleophilic attack. So here, what is a nucleophile? The methanol. And so here you're going to have phenol, and then we're going to have, this is an OH, another OH, and here I will have H and E, so that's formal positive. So here, let's do this, you can do this, and form, so proton transfer step. That is also can be solvent mediated. But now the point here is to have a better leaving group. Water is a good leaving group. And here I have OMe, and in reforming the carbonyl here, water will leave, so minus water. And here you're forming, this is the conjugate acid of methyl benzoate. So here, proton transfer step, and again, to remove that proton, I'm going to draw it on the other end. You can have methanol as base, for example. Remember that electron-rich species can be acting as nucleophiles, such as here, attacking on the carbon, but it can also work as base, same as water. So the final product of all this reaction is an ester, and the ester is this, and here to name that, this is coming from benzoic acid, so this is a metal, so we're going to say methyl benzoate. Again, with practice you will learn to recognize that, but understanding the mechanism gets you there without reasoning, say, without having so much memorization. But nitriles hydrolyze under acidic conditions to carboxylic acid, but they go first through the amide. So nitrile hydrolyzes to the amide continues to hydrolyze to the carboxylic acid. And the second step here is the Fischer esterification.